Okay, so today we'll work on modularization techniques in ABAP, SAP ABAP. So what is modularization? As of now, we have created many programs using joins, using for all entries, and we did some validations, right? So can you tell me, we'll talk about validations. Yesterday in the yesterday's program, we have validated the company code, right? Using some select statement and some logic. So are we going to do that validation only in a single program? Do we need that validation only in a single program, that company code validation? We might need it in the different programs also, right? Wherever we use a company code as an input, we need to validate it, right? In program A, we have a parameter company code in the selection screen. There we need to validate the company code. Again, in program B also we have a company code, that is sales order report. Sales order report, there is a sales order report, and in the sales order report also we have a parameter company code. So there also we need to validate, right? First we need to check whether there is any value or not, and if there is any value, we need to write a select statement to validate it in the check table, right? To validate the value, that logic has to be implemented in program B also. So let's say there is another uh, program, program C. There is in program C also we have a parameter company code. Again, we have to write the same code, right? Whatever we implemented in program A, B. Again, we have to write a if condition to check is there any value or not, and we need to write a select statement to validate against the check table and raise a error message, right? What are we doing in all these three programs A, B, C? We are writing same duplicate logic, right? In every program. Is it correct or not? Wherever we have this parameter as a this company code as a parameter, we are implementing the same logic again and again. Correct? So what if we can reuse the logic which we have implemented in program A in B and C? That would be convenient, right? If we can reuse whatever the logic we implemented in program A and B, program A, if we can reuse same logic in program B and C, that would be convenient. And also we are defining some standard functionality to validate company code, right? So that one user is working on program A, and user 2 is working on program B, and user 3 is working on program C. User in the sense developer, right? User 1 might implement a different logic in program A to validate the company code, and user 2 might use a different logic to validate the company code in program B. Similarly, user 3 might also use his own different logic, right? So there is no standard functionality we are using to validate company code, because three different developers are working on three different programs and they are going to implement their own logic, right? There is no standard logic, there is no proved logic they are going to apply. They are going to write some random logic, whatever they, as per their knowledge, they are going to implement it, right? One guy might just check value in the database. The other user did not check data against the database. He thinks that okay, user whatever the value user enters is correct. He may not write a select statement to validate it, right? So if we can make that logic, a specific logic, as a reusable logic, so that everyone can follow the same, right? They can just reuse it instead of writing their own logic for the same functionality. Correct? So this is common for any programming language actually. This is not specific to ABAP, right? This is common to any programming language. Okay. So in ABAP, we have different modularization techniques. So what do you mean by modularization? Modularization means breaking a, a complex business logic into reusable blocks. Okay, breaking a complex business logic into reusable blocks. Let's assume we are designing application. So this is application, and a program contains different logics, right? Like validations, passing the default values, or passing, writing the business logic, and displaying the output. There are different logic we have to implement in the program. Okay, what if we can break that logic into reusable blocks without writing a continuous code? As of now, we did not use any reusable blocks. We are just writing the code in the program, okay, in the continuous lines. What if we can break the program into reusable blocks so that you can use that block in different programs, other programs too, without writing same logic again and again, right? So let's say yesterday we have populated default values to the select option, right? Date for created date. In initialization, we have populated low, high, and options and sign, right? So if you have same requirement in a different program, without implementing again, without writing again, if there is already a reusable modularization block available, what we are going to do? We are just going to use that in a different program or different application. We don't need to write from the beginning. Okay, we can just reuse it, right? For example, so let's assume block means a reusable code or reusable module. So this is the program, and in the program we implemented the program using reusable blocks. Program 2. In program 2, we have a requirement which is exactly suitable to block A, whatever the functionality we implemented in block A. So instead of writing it from the beginning, what we can do? We can just call that block A here. We don't need to write it from the beginning. Okay. For example, here some default values populate some default values logic is here in block A. What you can do? So if you have same similar requirement in program 2, what you can do? You can just call block A in program 2. You don't need to write it from the beginning. Okay. So yesterday we have implemented a join statement, right, on EKKO table, EKPO and MAKT. In the program 2, if you have a similar requirement, same requirement to select data from purchase order tables, what you can do? Instead of writing it from beginning, you can call whatever the reusable block we have designed for that logic. Okay. For example, that is designed in block C, reusable block C. You can just call that reusable block C in your program. Similarly, these blocks can be used in any number of programs. Okay. You don't need to write it from the beginning. Clear? So let's see types of modularization techniques one by one. Types of modularization techniques one by one. I'm not going to discuss the outdated ones. Okay. We're going to work on the modularization techniques which are using in current S4 HANA environments, which are recommended to use. Okay. We'll forget about obsolete techniques. Okay. First one is include program. So what is include program? Include program is one of the type we created in SC38 programs. Okay. It is a modularization block. We can call it as a modularization block. Include program is one of the modularization technique where you can reuse the include programs. Okay. And you can implement some functionality in the include program, and you can reuse same include program in different executable programs. What are the programs we are creating as of now? We are creating executable programs. Then what is the difference between executable and include program? Executable program can execute on its own, right? You can execute the executable program, you can provide the inputs, and you can return the output, correct? But what is include program? Include program cannot execute on its own. Okay. So it is just for reusability. You can keep some code or logic inside the include program, and you can use this include program in another executable program. Okay. You can call the include program in another executable program. So when you add this include program to the executable program, what will happen? So whatever the logic you included in this include program, that will be executed as part of executable program. Okay. So you cannot execute the include programs independently. So when you add it to the executable program, then only whatever the logic inside the executable program will execute. Okay. Clear? So you can call this executable program in any other you can call this include program in any other executable programs. Okay, in any other executable programs. Yeah, that's enough. So it is one of the modularization technique. So where we keep the logic inside a include program and we are going to call that include program in different executable programs. Okay. So let's see the include program first. Twenty 21. Yeah, it's also open. Let's create a program, or or I or I'll do one thing. I'll modularize. I'll modularize this program. Whatever the program yesterday we have created. Shall we do that? Or do you want me to create a new program? Yeah. First, I'll copy this. I'll copy this into a different program. Select all. So whatever the options available in the program will be copied to the this new program. Change it. So first, I'll modularize the selection screen. So let's assume I have a similar requirement to have a same selection screen in different program. Okay. If there is such requirement, instead of creating from the beginning, what I can do, I can just call this reusable block. So how can you modularize this code using include program? Let's create a program first. So include program, one of the type of the program, right? Let's go and create a program. I'll show you how we can do it in multiple ways. Go to SC38. Please follow some naming convention. Okay. Please follow some naming conventions for include programs also. I'll take this as underscore top. Okay, underscore top. That means it is a it's a include in the top position. Top include means possibly we are going to store selection screens or any data, this internal table data element, any sorry, work area declarations, whatever available, we are going to keep in this include program. Okay, I'm just providing some naming convention, that is top. So that whenever I see this name, right, and include underscore top, I can assume what type of data in it. Mostly data declarations like internal table work area declarations and any selection screens. Okay, selection screen parameters. Create. Now tell me what is the type of the program you have to select. Include program. Select include program and click on save. Now copy all the data whatever available here, copy and paste it here. Pretty printer, and activate it. Program is activated, our include program is activated, right? Now remove the code from here. Now call this include program in your executable program. How can you call the include program? Using include statement. Include and the program name. Okay, check the syntax, no syntax errors, and activate. Now you have your selection screen, right? You have your selection screen, right? No changes. Now let's say there is another program with a similar requirement where I need to have same selection screen. Okay, what I can do, create one more program, one more executable program. Okay, some po underscore data 2. Type executable program. This is executable program. Now I need very similar selection screen, same selection screen. What I can do, do you need to write it from the beginning, right? Selection screen, begin of black, end of black, and do you need to define parameters and select options? So since we have only two, it may look very simple to define, but for some programs there might be 10-15 parameters also. Okay, now just reuse this include program in the program 2, executable program 2, that is include and program name. That's it. Check the syntax. Okay, dot inc, yeah. So this second program, right? So I don't need to define the selection screen again. It is automatically populating. Only text elements are missing. Okay, you have to maintain those text elements. Clear? You have to maintain those text elements. That's it. So this is how you can reuse a include program in a different program. Okay. So next, see second approach, how to create include program. We have this initialization part. We are populating data to AEDAT, right? We're automatically populating some data. depends on some condition. Let's say we have a similar requirement in different program also. So let's modularize this. Now I'll follow the second approach. I'm providing the name here itself, include default. Is this program already created? Is this program already created? No, right? We're just giving some name here. This is not yet created. This is not available, right? Double click on this, right? Like this, include and space, double click on this. Now we are creating from here. We are creating include program from the main program, executable program. Click on yes, create it, save, yes. So it will automatically populate the title. Click on save. So it will automatically populate type also, right? Save. What is your logic? Just keep your logic here. Control C, Control X. And place your logic here. Activate. Go back. Activate your main program. Is it populating the default values or not? Now I need similar requirement. I have a same requirement in a different program. Do I need to think about the logic? How to populate default values to the select options and how to populate and what is the logic? Do I need to think anything, any logic in its a different program? So just go to the program, initialization, then just use the include program whatever already created. For this, for the second include program, I have used a different approach. Create from the main program itself, right? Activate. It is populating here, right? Default values in the second program. This is second program, please observe, right? Next. Here we are validating, right? We are validating some company code, right? Shall we modularize this? Shall we modularize this company code? Logic, validation logic. Just do it. You can create separately. You can go to SC38 and create the include program, or you can create it from the main program also. So please observe, include program cannot accept any input and cannot return any output. Okay. Include program cannot accept any input or cannot return any output. Okay. Provide some name, underscore VAL. Let's use some name. Okay. VALDT. To create the include program, what we need to do? We just provided the name of the include program for validation. To create the include program, what we need to do? Double click on it. Double click on the program name. It will create the include program from the executable program itself. It will automatically populate the title and the type also. Activate the include program. We need to remove this here because it is duplicating the code. Go back. That's it, right? If you need the same validation in a different program, what you can do, just copy this include program, place it wherever you need, right? You don't need to write any logic. So whatever the validation logic available, it will automatically applicable to the so company code, right? Remove this and execute. So looks like you have to create text elements. That's it. It is not displaying the message. This text you have to create. Message error text you have to create because it's a different program, right? Those text symbols are available in the other program. Okay. Or just check why it did not copy. Usually it should copy text elements also. So it did not copy those text elements. You have to maintain text symbols here. That's it. But the validation is working. Only thing is you need to maintain the message. Let's modularize this business logic also. How to modularize? Let's create an include program. Now I'll use the first approach. How to create the include program? Go to SE38. I'll use the first approach, but that is not required. The first approach is not required. Okay. I'll use this logic. Okay. Create the program. What is the type you have to select? Include. So usually here we are saving in package, right? So when you are working on the project, you have to select a proper package and you have to select all these programs in a single transport request. Okay, because all these are related to single development. Okay, now place your business logic here, activate it, close it, include, sorry, what is the program name? PO underscore logic, right? Check, activate. Is it working? Yeah, it is working. Go back. If you want to use same business logic in a different program, what you need to do? Just copy this and place start of selection, and yeah, that's it, right? And if you want to display the output, you can also modularize this. Activate the second program, execute. We got the same output. Did we write any single piece of logic here in the second program? We just reused whatever the business logic we implemented in the program one, correct? By using include programs, right? So include program can be called in any other executable program or within the other include program. You can call one include program in another include program also. Okay, clear? But include programs cannot execute on its own. Okay, so include programs can be executable. So we can just add include programs to a executable program. So whatever the logic part of that include program will be executed along with the executable program. Okay, they cannot execute independently. So include programs cannot accept input and return the output. Okay, include programs cannot accept any input and they cannot return any output. So they'll just be part of some executable program. Yes, everyone clear? Yes. Mm, yes. Yes, like yeah, yeah, it's a good question. Like how to identify uh, there is already a reusable code available or not. So only thing you can go by is documentation or you can just search. There is no standard process to find reusable blocks, right? There is no standard process or there is no technical thing to find it. Just search by some PO data selection. If you can find any include programs, you can just check the business logic and analyze. Okay, is it suitable for my current business requirement or not? Then you are going to use it. See, usually how it works is like let's say you are working on an implementation project. What we'll do, you are going to work in not everyone is going to work in all the modules, right? So they'll assign you some module like sales and distribution module. Whatever the objects related to sales and distribution, they'll assign you like one or two members, they'll assign those module. Whatever the programs related to sales and distribution, you guys have to develop. So when you are creating these programs, and you are the guys, right, who's modularizing it, you are not going to write the continuous programs, right? You are going to write the programs with the help of include programs. Not only include programs, we have other techniques also, like function modules and class methods. You are going to modularize, right, the program, and you can have a idea, right? Let's say you are creating another program after 2 weeks in the same module, same sales and distribution module, and in that second program also, when you observe the technical specification document, okay, you have identified that okay, the business logic is very similar to the first program, whatever the modularization you did. Then you can identify, okay, I have already implemented in the different program the same logic, so that instead of writing from the beginning, I can reuse it, right? That's how it works. There is no standard process. Let's say you are in a support project. You recently joined in the support project. It is highly impossible for you to identify reusable block for that code until unless you have documentation, right? Documentation about all these reusable blocks, or someone in your team or your senior lead of that project who's working from the past 4 or 5 years, so they can guide you, right? Whenever you are creating the program, they can guide you. Hey, there is a reusable block already available for this logic, so you can use it, right? Or you can check with them. You can check with your lead or any senior developer in the project. Hey, can you tell me, is there any reusable functionality available for this sales order report? Okay. So usually in these days, like in S4 HANA implementations, what we are doing is we are going to create a class method, which follows object-oriented methodology. I'll discuss after 2 sessions or 3 sessions, right? Modularization mostly happening in class methods in these days. Okay, in these days. Okay, we are modularizing all the programs or business logic using class and methods. So we are going to create one common class for the project, and we are going to keep that reusable functionalities in this class as a methods, and everyone aware of that common class, right, in the project. So everyone, so when you joined in the project, they'll give you that common class. Hey, this is the common class for our project. Whatever the reusable functionality, we are going to use this class. We are going to add a new method to the class so that you can go to the class and check, right? So is there any reusable functionality available for your requirement or not? So first we'll check like include programs and function modules and subroutines, and then we'll work on object-oriented class methods. They are very important, okay? Because nowadays everyone is preferring to use object-oriented methodology or object-oriented programming in their projects, okay? But still, where we use include programs, function modules, right? Because there are a lot of thousands of standard functions available in SAP. Thousands of standard function modules available. Function modules are nothing but some functions. If you are aware of any other programming language like C or C++, you can easily recollect that. Functions are nothing but some functions which follows procedural programming language. These are not related to object-oriented programming. Okay. There are a lot of standard functionalities, function modules provided by SAP. You can just call it in your program. Okay, you don't need to write any business logic. For example, to find holidays in a current year, there is a standard functionality provided by SAP. Okay, so to calculate the days or to calculate the number of weeks, there are different function modules provided by SAP. You can just reuse it. If you need a custom functionality, what you need to do? You need to create your own function. We'll see that. Is everyone clear on include programs? So include programs can be called in any other executable program, right? So next modularization technique is subroutines. I'll provide some syntax here to call the include program, include and program name. Now we'll see second modularization techniques, that is subroutine. What is a subroutine? Subroutine is a reusable block which is local for the same program. Or I can say like this. We can reuse within the same program. Can we call the include programs in other programs or not? We can call the include programs in any number of other programs. But when it comes to subroutines, you can use these subroutines only within the same program. Only within the same program. We cannot reuse subroutines in any other program. Okay, it is local to the same program. Okay, so how to define and call the subroutine? So to call the subroutine, we need to use a statement perform and subroutine name. The logic will be in between form and end form. So the logic will be available in form and end form. Okay. So to call the subroutine, we use a statement perform. Okay. So here we have, you can also pass parameters. Subroutine can accept the input and return the output. But include program cannot accept the input, but subroutine can accept input and returns the output. Let's see how to use a subroutine. Let's create a program on subroutine. Create the executable program. Save. So how subroutines will work? I'll also need to make one more important statement. So form and end form, right? This form and end form should be last statement of the program. You cannot use in between the program lines. So form and end form should be the last program. This should be the last statement of the program. You cannot use form and end form, okay, before any executable statements. Okay, form and end form should be after all executable statements. Okay. So form and end form should be after all executable statements of the program. Okay, right? Now let's see how to write a subroutine. Let's assume we have perform. I'm providing the name of the subroutine. Add or first define two parameters. Parameters p underscore 1 type some integer, p underscore 2 type some integer. Now add two numbers dot. Double click on this to create the subroutine. Where is it? Perform add two numbers. This is my subroutine name. Double click on it, or without double clicking, what you need to do? Form add two numbers, end form. Form and end form. In between, write your business logic, whatever the logic required. For example, these are global values anyway. Uh, Data of LV underscore output equal to plus 2. Okay. Check the syntax. See, we are using inline declaration, right? Here, we are using inline declaration, but this CL demo output is not able to access this variable, right? Because this variable declaration is after this statement, right? This variable declaration is line number 24, but we are trying to access that variable in line number 20. It is not working since we are using inline declaration here, right? So let's try to place this CL demo output after the form and end form. Is it going to work? Let's check. What is saying? Still it is unknown. So here inline declaration may not be suitable in this scenario. Inline declaration is not suitable for this scenario, right? Because where are we defining the variable? Is it inside the subroutine or not? Are we defining the variable inside the subroutine or not? So this is local to the subroutine. So whatever the variable you defined inside the subroutine, that is local to that subroutine. You cannot access that value outside of that subroutine. Okay, this is local. It will create local memory for this subroutine. You cannot access that variable outside of the subroutine. Clear? For this, what you need to do? You need to create a global variable. What is global variable? Define here. Define in the top data. But let's try calling this inside the form and end form before that, before creating a global variable. Now it should work. It is working, right? Because the statement is able to access LV underscore output because we are inside the subroutine, right? It is trying to access. So please observe. So whatever the variables you defined inside the subroutine, that variable is local to that subroutine. You cannot access outside of the subroutine. Okay, clear? To make it global variable, what you need to do? Define here in the top. Type I. Remove here, remove the data statement here. Now let's try keep this outside of the subroutine. Are we able to access it or not? Now we don't see any error, right? So we are able to access this value outside the subroutine also because it's a global variable where we defined it in the top, right? So this variable value can be accessible throughout the program in any part of the program. Okay, it is not local to any event or any specific subroutine. Let's execute this. 10, 20. You got the output 30, right? So how we are calling the subroutine? Using statement perform. By using perform statement, we are calling the subroutine. We are writing business logic inside form and end form. Okay. So always remember this form and end form should be after all executable statements. Let's try to use write statement here. Write LV underscore output. What it is saying? What it is saying? Statement is not accessible. Statement is not accessible. So whatever the logic or whatever the statements you write after form and end form is not going to be executable. They cannot accessible. We cannot execute those statements. Okay, that's why form and end form should be the at the end of the program always. Okay, check the syntax. It can accept now. Okay, clear? Then again, if you need to execute subroutine one more time, what you need to do? Just call the perform at numbers, right? So like this, you can call the same subroutine any number of times within the program. Clear? Using perform statements. But it is local to this program. You cannot call the same subroutine in other programs, separate, different programs. So these subroutines are local to same program. Let's see how we can pass the inputs and return the outputs. Let me create one more time. Perform add numbers using, what is using? Using is used to pass the inputs, pass the input values. Okay, using is used to pass the input values. For example, p underscore 1 space p underscore 2. Okay, p underscore 1 and p underscore 2. Now let's double click on it. Double click on the subroutine, or you can define on your own using form and end form. It is saying incorrect cursor position. Maybe I need to use dot. Yes, dot is missing. Create the subroutine. So it is asking, do you want to create a new include program for the subroutine? So you're going to keep all your subroutine definitions in a include program. No, I don't. I just keep it in the master program. Select the master program. Continue. If you observe this, it is automatically created a subroutine, right? It is automatically created a subroutine definition. Now, inside this, we have two values using p underscore 1 and p underscore 2. Now, write your logic lv underscore output equal to this one you have to use now plus 2. Activate. Display the output. So we got the output. Now, if you need to calculate different numbers, if you need to calculate different data, if you need to add different data, what you need to do? Again, sorry, perform. Call the subroutine one more time. Perform, add numbers and pass the variables, pass some values. 10, I'll pass like this. Using, okay, I have to use using 10, 20. Let's see how it will work. I'm passing my own values. Maybe you need to use single quotes. So since these are integers, we don't need to use single quotes. Let's try how it will calculate. Now I am passing some hard-coded values. Anyway, since we have parameters, let's enter something. So it is able to calculate, right? So similarly, you can call this perform any number of times. Perform. Let's do one thing. Uh, perform add numbers using lv underscore output space lv underscore output. Let's see how it will calculate. Execute. It is calculating, right? So for each perform, it will go to form and end form and execute the logic. Clear? Keep a breakpoint here. execute the program. 4 plus 4 8. Now we are calling the subroutine using these two parameters, parameter 1 and parameter 2, F5. If you click on F5, where it will take to the form and end form, it will calculate the data. Now it will come to the second subroutine. If you click on F5, what will happen? Again, it will go inside the subroutine, right? Clear? Let's observe a very important thing here. If I click on F5, what will happen? It will go inside the subroutine, right? Again, it will execute whatever the logic inside the subroutine. Now we are in another perform call. Now if I click F6, what will happen? Instead of F5, I'm pressing F6 or this one, single execute. Instead of F5, F6. I click on F6. Is it going inside the form and end form? And is it executing the logic? No. It is completing complete execution in single step. If you click on F6. Clear? If you want to complete this perform or execution in single step, you can use F6 here. You don't need to use F5. Execute again. Now if you click on F5, what will happen? It will go inside the subroutine and execute line by line, right? If you click on F6, it will complete the execution in single step. F6. Let's say if you click on F5 here, it will go inside the subroutine. If you want to come out of the subroutine without executing all the lines, what you need to do? F7. If you click on F7, it will come out of the subroutine without executing line by line. That doesn't mean that it is not going to execute the code. It will execute the code in background. Okay. If you click on F6, it will execute the code in background and come out of the subroutine. Since we have only one line here, you cannot observe the difference, right? Going forward, you can see. I'm pressing F7. It will come out of the main program. If you click on F7, when you entered into the subroutine. Clear? But to execute the subroutines line by line, if you click on F5, it will enter into the subroutine and again you have to execute line by line, right? If you don't want to execute line by line, just press F6. It will complete the execution in single step. F6, right? Now you can observe the difference between F5, F6 and F7 when you are working on the subroutines, right? And even include programs also. Is it clear for everyone? So subroutines we are hardly using in these days. Instead of subroutine, what we are using? Object-oriented class methods. No one is preferring to use subroutines. Even in your programming project programming guidelines, they'll clearly mention. So don't create any new subroutines as long as it is very mandatory or there is no other functionality it is supporting. Then only we have to go for subroutines in the report programs. Okay, clear? Yeah, we still use subroutines in other concepts. Okay, but in programs, in report programs, don't prefer to use subroutines. Instead of that, we have to use object-oriented class methods. But for now, practice programs using subroutines until we discuss the object-oriented class methods. Okay, because we still use subroutines in other areas like in sales and distribution, we have a concept called VOFM routines, output conditions. At the time, we should use subroutines. Okay, you should have knowledge on subroutines. So what is the difference between include programs and subroutines? Include programs can be called in any program, but subroutines are local to the same program. Include programs cannot accept input and cannot return the output. But what about the subroutine? Subroutine can accept the input and return the output, right? And form and end form should be the last statement of the program. It should not be above the any executable statements. Okay, because they are not going to be accessible. Clear? Try creating subroutines and try to debug it so that you can understand how F5, F6 and F7 we can use. Clear? So by using what is using? By using this statement using, we can define the inputs, right? How many inputs we defined here? Two inputs, right? Let's say I'm passing only single input. Is it going to accept? It's not going to accept. What it is saying? Different number of parameters in form and perform. So you defined two parameters in form and you are passing only one parameter in perform. Let's say that is your requirement. You don't have other parameter to pass and you don't know what is the value. Just pass some empty value like this space. Okay. In place of that second parameter. Clear? If you don't want to pass all the parameters, just provide some empty space. Okay. Clear? I will stop here and tomorrow we'll work on function modules. It is very important modularization techniques because we are going to use a lot of standard function module in your programs. Okay, but when it comes to create new functionalities, what do you prefer? Do you prefer function module or class methods? We need to prefer class methods, but there are still some functionalities like RFCs, BAPIs, interfaces. Those things we have to implement in function modules only. Okay, but for reusability, but for reusable functionality, so we should always prefer class methods, but still we have to use function modules because all BAPIs interfaces are depends on the RFC function modules. Okay, we'll discuss one by one, and for today we'll close the session. Please practice these two modularization techniques, that is include program and subroutines.